Good morning, everyone. And so I'll quickly go through. I have 20 minutes, right, Joy, for this session?
You have 30 minutes.
30 minutes. Okay, great. That's great to know. So, good morning, everyone. So, my name is Praveen. I'll be going through some of our work in the field of net zero initiatives from Surbana Jurong Group. Just give me a minute. Okay, so Surbana Jurong Group is one of the Asia's largest urban infrastructure and managed services consulting firms. So we have within Surbana Jurong Group, we have 9 group companies. So as you can see here, so from 2015, Surbana and Jurong were 2 different firms. It was combined to be the one of the largest in Singapore, and then we had so many companies joining the group from 2015 till over a period of 5 years. We have 9 group companies as of now. So Surbana Jurong as sorry, start my video. Oh, sorry, I didn't know that my video was not started. Okay. So Surbana Jurong has built more than 1 million homes in Singapore and created master plans in more than 30 countries and developing over 100 industrial parks globally. Our tagline, Building Cities and Shaping Lives, expresses how every project or undertaking from the group is an opportunity to fulfill the aspiration and enrich lives, and also as a push in our SJ 2.0, which is in our internal initiative to focus more on sustainability. So today I'm happy to present some of our recent projects or the initiatives that the group has undertaken in terms of net zero. So Jurong is one of the Temasek portfolio companies, and we are under the consumer and real estate wing of Temasek. And in terms of our global experience, so we have ranked 24th of the top 225 international design firms with a revenue of 1.7 billion. We have global workforce of 16,500 plus even more, I think close to 17,000 now, and we are present in more than 40 countries with 120 offices overall. So this will be all in terms of our partners. We have worked very closely with private partners, we have government sectors, and we also have multilateral international organization with whom we work very closely. So this is a quick snapshot on the group, what we do, who we are, and next, I will quickly go through some of the projects. So I've covered 3 projects in total. So the first project is from Surbana Jurong Consultants from Singapore side, and I'll be presenting 2 or 3 projects from B plus H. So unfortunately, due to the time zone issues, Lisa is not able to join, who is our sustainability leader from B plus H. So I'll be covering a couple of projects from B plus H as well. So the first project will be the NUS School of Design and Environment. Okay, so this is a project team. So the architects ESD, we call it as a multidisciplinary team, is from Surbana Jurong Consultants Private Limited, which includes architects ESD, CNS, MNE, QS, and landscape consultants. The client is National University of Singapore, and design architect is Seri and Multiply, and we have a few other partners in like Transolar and Kajima. So this is a project photos, like how it looks like. We are very proud of this project. Even Joy was part of this project before she joined World Green Building Council. So in terms of the location, this project is located within NUS campus. So the total site area is around 5,000 square meters, GFA are around 8,600 square meter. We have 6 floors, and with the total construction cost around 33 million. So this is the project location. It's along the Clementi Road within NUS. So many of the first, so this building is Singapore's first new build net zero energy building. So the building is also a hub for test bedding of green building technology. The sustainable design of NUS SDE4 defines a new standard for energy efficient buildings in Singapore. So also it was actually a pilot project for Institute of Higher Learning in Singapore, and also it's a first building which has achieved well certification in Southeast Asia for institutional or higher learnings, and the first large-scale hybrid cooling coverage. And also we also have on-site renewable energy. We don't have any off-site and no carbon credits. Everything is offset using on-site renewable energy. So these are the many firsts for this project. And also recently it was awarded the leadership in sustainability under the carbon performance category by Singapore Green Building Council in the recent the awards night. So I'll come to the key strategies. So uh, in tropics, I would say it's a challenge, as I think if you know tropics very well, um, the temperatures are very high. It's very humid, and to convert some of the building or to construct a new building and to make it as a net zero energy building is extremely challenging. Uh, it's because unlike other cold countries, we don't have any other renewable energy resource except the solar PV, which is quite promising and also quite proven. But we don't have geothermal, we don't have any other renewable energy, so it's very challenging. So we need to make sure that the design is uh, we have a good design, it's very tight, and we achieve maximum energy saving in terms of optimizing the design, and then whatever leftover we offset with the renewable energy. So in order to achieve the targets, the design team has come up with a four-pronged approach in terms of firstly in terms of net zero energy, which is reducing energy consumption, maximizing renewable energy production, and synergy of passive and active design. As you can see in this image, if it is a business as usual, we might have need almost like three roof space of what we have. So because we optimize the design, we reduce the cooling load, we actually make it a very efficient building in the first place, so that we need less number of PV panels to offset the energy consumption. The next approach is smart building. So we use extensive sensor network, response to environmental conditions, a building that it's talks to its occupants and managers. So in terms of smart building operations, so later I'll show you some of the instrumentation that we did in terms of measurement verification. So in terms of health and well-being, so we incorporated uh, the 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 fundamentals of the biophilic design, enhancing occupant well-being, and also it's a well certified as well, as I mentioned. And in terms of innovative design, it's a very vibrant social and collaboration spaces. It has various test beds for experimental learning. It's also a living lab where actually building technologies can be tested. So it's a building not just for its occupants, and it's a live building where it can actually be tested and demonstrated for future of Singapore. So in terms of optimization, so since I have a limited time, so I'll quickly go through some of the key strategies. So in terms of the passive design, so we actually optimize the massing in such a way that the building is oriented properly, which is, I think, in tropics, the east and west is quite bad. So we oriented the building pure north and south, so that we have minimum 6 months of shading for the north and south. So the sun path is very symmetrical for uh, for in Singapore. So it makes sense that we orient towards the north and south, and we have enhanced the natural ventilation. So we adopted the strategies like loosely stacked buildings, very porous, and it's the depth is not that it's not a big depth. So we made it big porous so that it's the most of the common areas can be naturally ventilated. And also we have, as you can see, we have blocked the east and west with the additional wall, and we have the entire roof being utilized. We have an overceiling roof, as you can see, and this roof has been utilized to mount the PV panels. So these are some of the passive design strategies that we adopted. And this overselling roof is not only helps to increase the area for our PV panels, but importantly it will actually cut the direct sunlight which is coming in, but it will help to diffuse the daylight, and also it will help to provide the necessary shading for the facade. So in terms of functional spaces, so as I mentioned, so this particular building has various spaces for research. We have design studios, we have prototype workshops, and also we have spaces for industry collaboration. So just an example, like in the level 5 and 6, we have facade test bedding areas. In third story, we have model smart green home, which is testing of sustainable home solutions. And in second story, we have green building technology lab. So it's basically a living lab which demonstrate how net zero energy building can be designed and can be sustained in a tropics, and also it actually provides a path for future integration of new technologies and collaboration. So in terms of the energy, so as I mentioned, so we did a lot of optimization. So this is the energy consumption in terms of reference building. So reference building is actually a typical institution building, and in terms of optimization, the first step was always a passive design optimization. So some of the strategies which I just now mentioned in terms of natural ventilation, shading, optimizing the daylight, and everything. So we're able to reduce the energy consumption to a greater extent. We reduce the load in the first place, and then with the help of active design. So later I'll touch base on what kind of active system we utilized. So in terms of active system, so we're using hybrid cooling, using efficient electrical system, we're able to reduce energy. Then finally, we did further optimization in terms of equipment selection and plug load management, and all these contributed to reduce the energy consumption. And finally, we were able to achieve close to the total consumption is around less than 500 megawatt hour per year, which was then compensated by using the PV panels. So as I mentioned, it's a very iterative integrated design approach, wherein it's a very conscious decision from the entire multidisciplinary team to optimize the building in such a way that the renewable energy only comes in after we optimize the entire building, and it should not be the only solution to offset or to make it net zero. Yeah. So the keywords are integrated design process and the performance-based design. So this is a typical a studio. So just to show example of how we optimize the space. So we have firstly we have an overhang which actually will cut down the direct solar heat gain, and it will diffuse the daylight. We have lamellars here. These lamellars are tilted around 15 degrees. This can be further tilted. You can close the lamellars. It will also help to further distribute the daylight evenly into the space. And we have openable facade. So that means if it is favorable, the weather is favorable, we can open up with the help of ceiling fan. We can make it as a naturally ventilated space. And by default, we have a hybrid cooling. So this hybrid cooling includes a mechanical ventilation, which is treated but not too cold. Typically in Singapore, we cool the air around 13 to 14 degrees decoil temperature to cool the space, but in this case it's very high. It's around 17 to 18 degrees, and then we maintain the indoor temperature around 27 to 28 degrees, and with the help of ceiling fans we achieve the same thermal comfort what any other typical building can achieve. So this is a strategy that were adopted, and most of the common areas is naturally ventilated, and this was achieved again by optimizing the passive design. And these are the instrumentation during when we're doing the testing and measurement and verification. So we employed a very comprehensive measurement verification. This was actually a mock-up that we did with the sensor setup, stratified sensors, to measure the performance. And we recently cleared the stage 1 and 2 verification, and in fact we now this building is not only net zero, it's a positive energy building. That means it generates more energy than what is being consumed. And also this building has achieved so many awards. So you can see as our colleagues, you can see Joy here, so myself. So this building has achieved Green Mark Platinum and Design Prototype, and also it's achieved Sustainable Cities and Human Settlement Award. So this building is a testimony and also a living example that net zero energy buildings are possible in tropics, but we need to take a right step at early design stage. We need to adopt a performance-based design approach and also a integrated design approach in order to make sure that we achieve this without sacrificing either the functional needs and also the indoor air quality or the wellness of the occupants. So this is a project from Surbana Jurong Consultants, and I'll quickly touch base on few more projects from B plus H. So initially Elizabeth was supposed to present this. Because of the time zone, she's not able to join today, so I'll be covering this from B plus H. So as similar to our group, so sustainability is very key decision making, and also it's at the heart of the design process in from B plus H, and it can be seen in some of the projects that they have delivered. So I'll go through some of the projects which have achieved net zero carbon certification. So in terms of services, they provide architecture, interior design, planning and landscape, and advanced strategies. These are some of the service offering from B plus H. And uh, in terms of design, B plus H is committed to environmentally conscious and high performance and resilient design. And this is, and as a testimony is that they've close to 70 projects that are certified or registered for LEED, Green Mark, or other green rating system, because they are actually placed all over the world. So they have also have few projects which are China 3-star, net zero passive housing, and a few other certification. So these are some of the projects. So B plus H was awarded the two of the first Canada Green Building Council net zero carbon design and operational certified buildings in Canada. So these are the two projects. One is a new building, one is the retrofit. I have one more building, so basically covering 3 project examples. So first is Mohawk College, which is a Joyce Center for Partnership and Innovation. So this particular building has achieved the first net zero carbon design and operational performance certified building in Canada. And the Humber College, which is actually a retrofit, which also achieved the first net zero carbon design certified, and Passive House Canada. And later I'll show you some very good design principles that was adopted. So this is the first project, which is in Gatineau, which is in Quebec in Canada. So this is currently being, it'll be completed in a couple of months. It's targeted to complete by in 2022. So this has a total GFA of around 12,000 meters square. So in terms of functional use, it is mainly used for library and for archives. So in terms of sustainability achievements, so this is the first net zero carbon facility dedicated to archival preservation in the Americas, and first federal building constructed to the requirements of Canada's greening government strategy, and also it's targeting the net zero carbon building design certification. So quite a good achievement. So these are some of the perspectives, the images of the building. Sorry. Yeah, these are some of the few more images of the building. So again, so the base, the strategy was performance-based design, integrating the sustainable design strategies, and then offsetting the renewables with renewables. And the second project is Mohawk College, which is Joyce Center of Partnerships and Innovation. So this is located in Hamilton in Canada. So it's completed in 2017 with a total GFA of around 23,700 meters square. So in terms of sustainability certification, it is the first net zero carbon design certified building, and is also like a prototype, like what we did for NUS. NUS was a prototype. NUS SDE4 was a prototype for Institute of Higher Learning. Similarly, this building was a prototype for an institutional building. And some of the awards includes Royal Architecture Institute of Canada Innovation in Architecture Award in 2019, and also it has achieved the Canadian Green Building Council Greater Toronto Chapter Innovation and Sustainability Award. And this is the project, how it looks like. And as you can see, we have somewhat similar strategies that we have. Of course, we have other strategies when it comes to active design. Again, the key principles of passive design, shading, optimizing the renewable energy. So these are some of the images of the project. So we have renewable energy at the top of the two big overhangs that we have, and you can see the indoor spaces are very well lit. We have a lot of daylighting. We can cut down on artificial lighting. We have enhanced natural ventilation to a greater extent, and even the active designs are designed in such a way that it meets the wellness and the well-being of the students and the occupants. So in terms of the EUI, so this chart shows the difference between a typical Toronto office building versus what we achieved for this project. So if you see a typical Toronto office building is in the EUI, in terms of EUI is measured in terms of kilowatt hour per meter square per annum, which is typically around 450 to 550 kilowatt hour per meter square per annum, and average Canadian office building is around 355, and average LEED certified building is 162. But the building that and some of the projects that's completed by B plus H is less than 90 kilowatt hour per meter square per annum, and the project that we're discussing is around 72 kilowatt hour per meter square. As you can see, compared to a typical LEED certified building, we almost half the energy consumption. So this is actually a testimony to the kind of design optimization that we undertake before even we think of renewable energy. So this is actually, in summary, some of the key design strategies: optimized daylight and glazing, integration of the green spaces in terms of green roof, and improved tree planting, and also measurement verification. We have actually adopted a very comprehensive IPMVP in terms of measurement verification, optimized active systems. We have utilized ground-based heat pumps. We also have we have heat pumps. We have also have a ground-based geothermal energy, which helps us to achieve some of the net zero credentials. Very tight envelope and also high performance facade. So we have a triple glazed double low E coating, and we're also doing it's a lot of work in terms of water sustenance. We used low flow fixtures, stormwater harvesting, and water efficient irrigation system. And we also this building also provides and encourages use by bicycles, and they have bicycle facilities at grade. And in terms of other credentials like net zero carbon certified, and also 75% better energy performance, as I mentioned. And in terms of renewable energy, we have close to 545 kilowatt peak. So that's the capacity of the renewable energy. So we also used the ground-based geothermal energy, which is actually can span up to 5.2 kilometers of wells and piping in total, and it goes as deep as 180 meters. So this is what I've mentioned in terms of the EUI just now. So compared to the first iteration, so this is a kind of different iteration that we did, similar to the one which I showed for NUSSTE. We did various iteration, and higher importance was given to passive design optimization, and followed by active design, plug load management. We are able to achieve a total EUI of 72 kilowatt hour per meter square per annum, which is quite a massive achievement, where you need both cooling and heating at different point of the time. And in terms of embodied carbon, the embodied carbon in this particular, we have actually integrated those low carbon construction kind of ideas, so which help us to reduce the embodied carbon to a greater extent. And this is actually the breakdown of the embodied carbon for this project. And also this project was it made a news, and it was visited by even some of the key dignitaries, includes Canada's environmental minister. We visited to the facility, they took a look, and also it was visited by various dignitaries as well. And these are some of the awards that is received by this particular project. So maybe I'll just skip and go to the last two projects. And this is the last project, which is Humber College building in Toronto, Canada. So this completed in 2019. So this has a GFA around 4,800 meters square. So this is actually a retrofit of original building built in 1989. So this is a perfect example of how we can actually repurpose the building without demolishing, and that actually we can reduce a lot of embodied carbon by not doing this, and by just redeveloping the existing building. And so in terms of certification, so it's a net zero carbon design certified, the first net zero carbon certified for a retrofit building in Canada, and also it's targeting passive house certification as well. So this the building while it was under construction. As you can see, we just used the base building structure, and then we optimized the facade in terms of insulation and some of the glazing. And also we are proud to say that Prime Minister visited this building, Prime Minister of Canada, and he also gave us talk on how the built environment can be more sustainable. Yeah, so we are very proud of this this project. Yeah, that's it. Thanks, Joy. So that's some of the projects. So although we have many other projects from the group, so we have picked these few projects for this presentation. And from being a consultant firm, a professional consultant firm, we strongly believe that net zero energy buildings are possible, and that's the reason we demonstrated these projects in different climate zone, be it in tropics, be it in cold climates. If you have an intent, a right vision, and an intent, we should be able to achieve net zero buildings. Yeah, it's very much possible. Thank you.